Welcome to this comprehensive module on Kubernetes package management examples. In this session, both practical experience and theoretical knowledge is presented to help you understand how to effectively manage applications in Kubernetes using Helm charts. In this module, we'll explore real-world examples of Kubernetes package management, focusing on Helm charts and their practical applications. We'll start with basic examples and progressively move to more complex scenarios, ensuring you gain hands-on experience with package management in Kubernetes environments. By the end of this module, you'll be comfortable creating, modifying, and deploying Helm charts for various applications, from simple Hello World examples to more complex multi-service applications. Let's begin this exciting journey into Kubernetes package management. Let's begin with the fundamental structure of a Helm chart by examining a Hello World example. This example, while simple, introduces the core concepts and structure that you'll use in more complex charts. The Hello World chart follows a standard directory structure that's crucial for any Helm chart. Let me break down this structure for you. At the root level, we have the Hello World directory, which contains three essential components. First, there's the chart.yaml file, which serves as the chart's identity card, containing metadata about your package. Second, we have the templates directory, which is where all your Kubernetes resource definitions reside. And third, there's the values.yaml file, which stores default configuration values that can be overridden during deployment. This structure might seem simple, but it's incredibly powerful. It's the same structure used by enterprise-level applications, just with more components. Understanding this structure is crucial because it forms the foundation for all Helm charts you'll work with in your DevOps career. Now, let's examine the chart.yaml file in detail. This file might look deceptively simple, but it's a crucial component of your Helm chart. The chart.yaml file we're looking at contains two essential fields. The API version, which is set to v2, indicating we're using Helm 3's chart format. And the name and version fields, which identify your chart and its current version. While this example shows the minimal required fields in production environments, you'll want to include additional metadata such as description, maintainers, and dependencies. This information becomes invaluable when sharing charts across teams or publishing them to a chart repository. While working with enterprise Kubernetes deployments, proper versioning in chart.yaml may save countless hours of troubleshooting. It allows teams to track which version of the chart is deployed in different environments and roll back to previous versions if needed. Remember, the version field in chart.yaml follows semantic versioning principles, major.minor.patch. This becomes particularly important when you're managing multiple environments or when other charts depend on yours. Let's dive into one of the most important files in our Hello World chart, the deployment.yaml template. This file demonstrates the power of Helm's templating system and how it brings flexibility to your Kubernetes deployments. The deployment.yaml file we're examining is a Kubernetes deployment resource definition with Helm template directives. Let's break down the key elements. The name field uses release.name deployment, which dynamically generates the deployment name based on your release name. This is a powerful feature that allows you to deploy the same chart multiple times in the same cluster without naming conflicts. The replicas field references values.replica count, pulling the value from your values.yaml file. This templating approach allows you to modify the number of replicas without changing the template itself. In the container specification, we're using Nginx latest as our image. While this is fine for learning, in production environments, you should always specify exact version tags for predictability and security. One common gotcha I've encountered in production environments is forgetting to properly scope the match labels and labels. Notice how we use release.name consistently across these fields. This ensures proper pod selection by the deployment controller. The container port specification of 80 is typical for web applications, but remember that in production environments, you might want to make this configurable through values.yaml as well. Now let's examine the values.yaml file, which is crucial for making your Helm charts configurable and reusable. In our Hello World example, we see a simple but powerful configuration. The file contains a single value, replica count, 3. This means our deployment will maintain 3 replicas of our application by default. While this looks straightforward, it demonstrates a fundamental principle of Helm: separation of configuration from implementation. In real-world scenarios, your values.yaml file would contain many more parameters. You might include resource limits and requests, environment variables, service configurations, ingress settings, storage requirements. One valuable practice I've implemented in production environments is to maintain different values files for different environments. For example, values.prod.yaml, values.staging.yaml, and values.dev.yaml. This allows you to maintain consistent templates while adjusting configurations per environment. A word of caution: while it's tempting to make everything configurable, focus on the values that actually need to change between deployments. Too much configurability can make your charts harder to maintain and understand. Let's discuss how to put our Hello World chart into action. The usage pattern we're looking at is fundamental to working with Helm charts. The basic installation command is helm install my hello world /hello world. This command does several important things. My hello world becomes the release name, which you'll see reflected in the deployment name. /hello world specifies the chart location. The beauty of Helm becomes apparent when we look at how values are processed. Values from values.yaml are used as defaults. These can be overridden using the -miniset flag during installation. In production environments, I've found it crucial to use version control for both the chart and values files. This provides an audit trail of configuration changes and makes it easy to roll back if needed. A practical tip: always use descriptive release names that identify both the application and its purpose or environment. For example, prod API gateway or staging auth service, rather than generic names like my release. Now we're moving from our Hello World example to a more realistic application, a guestbook application. This example demonstrates how Helm manages multi-component applications in Kubernetes. The structure we're looking at shows a more complex chart organization. We have multiple template files, each managing different components of our application. The front-end service, back-end deployment, and Redis deployment are separated into different files. This separation of concerns makes the chart easier to maintain and understand. This structure represents a common pattern in microservices architectures. Keeping services in separate template files while maintaining them in a single chart may strike a good balance between modularity and manageability. The guestbook example demonstrates how Helm can orchestrate the deployment of interconnected services, managing their dependencies and configurations in a unified way. This is particularly valuable when you need to ensure consistent deployment across different environments. Here are the contents of the chart.yaml file shown in the structure earlier. It simply has the API version, name, and version number. Let's examine the front-end service.yaml template in detail. This file demonstrates how to expose your application to users through a Kubernetes service resource. The template includes several dynamic values pulled from values.yaml. .values.frontend.port defines the service's listening port. .values.frontend.target port specifies where traffic is forwarded. .values.frontend.service type determines how the service is exposed. These configuration options give you flexibility in how you expose your application. For example, in development, you might use Node port for simplicity, while in production, you typically use load balancer or an ingress controller. Using Helm's templating for these values saves significant refactoring effort later. A pro tip: always consider security implications when exposing services. In production, you might want to add additional template logic for security configurations like network policies or TLS settings. Moving on to the backend deployment.yaml, this template showcases how to configure a more complex deployment that interacts with other services. Key points in this template include dynamic replica count through, values.backend.replica, count, environment variable configuration for Redis connection, details, container port exposure for service communication. The environment variables Redis_host and Redis_port demonstrate how Helm templates can configure service discovery. This is crucial in microservices architectures where services need to communicate with each other. In real-world deployments, I've found it essential to also include resource limits and requests, readiness and liveness probes, security contexts, service accounts. These additions make your deployments more robust and production-ready. Consider adding them to your templates as you move beyond basic examples. The Redis deployment.yaml template represents our data store component. While relatively simple, it demonstrates several important concepts in Helm templating. The template configures dynamic replica count using values.redis.replica, count, standard Redis port 6379, basic pod labeling for service discovery. In production environments, you'd want to enhance this template with persistent volume claims for data storage, Redis configuration options, security settings, backup configurations. Some teams struggle with data persistence in Redis deployments. Always consider stateful service requirements carefully when designing your Helm charts. In production, you might want to use stateful set instead of deployment for Redis. The values.yaml file for our guestbook application demonstrates how to organize configuration for a multi-component application. Let's analyze its structure and best practices. The file organizes values by component. Front-end configuration includes service type and ports. Back-end configuration specifies replica count. Redis configuration includes host, port, and replica count. This organization makes it clear which values belong to which components, making the configuration easier to maintain and update. In production environments, I recommend adding comments to document each value's purpose, including validation ranges or allowed values in comments, grouping related values logically, using consistent naming conventions. Remember, while our example shows basic configuration, real-world applications often need many more configuration options. However, always balance flexibility with maintainability. Not everything needs to be configurable. Let's explore how to use our guestbook Helm chart effectively. The usage examples demonstrate both basic installation and value overrides. The basic installation command is straightforward. Helm install my guestbook /guestbook. For customization, you can override values. Helm install my guestbook /guestbook -miniset frontend.port equals 8080. In production scenarios, I recommend using values files for different environments instead of -miniset, documenting deployment procedures, implementing pre- and post-installation hooks if needed, setting up proper Rebake permissions. One crucial lesson from real-world deployments: always verify your services after installation. A successful Helm installation doesn't always mean your application is running correctly. Let's explore the essential Helm commands that you'll use frequently in your DevOps workflow. These commands form the backbone of your day-to-day interactions with Helm charts. The Helm status command is crucial for monitoring your deployments. When you run Helm Status My Hello World. It provides comprehensive information about your release, including the deployment state, the resources that were created, any notes specified in the chart, recent events related to the release, the kubectl get deployments, command complements, Helm Status command by showing you the actual state of your deployments in Kubernetes. This is particularly useful for verifying that your desired state matches the actual state in the cluster. Finally, the Helm uninstall command is your tool for clean removal of releases. When you run Helm uninstall my guestbook, Helm ensures that all resources associated with the release are properly removed, preventing resource leaks in your cluster. A word of caution from real-world experience. Always verify the resources you're about to remove before running uninstall, especially in production environments. You might want to use -ministry run first to see what would be removed. Now we're moving into the hands-on portion of our module. The assignments ahead will give you practical experience with Helm chart creation and management. These exercises are designed to reinforce the concepts we've covered and help you develop real-world skills that are valuable in DevOps roles. Through these assignments, you'll learn how to set up and configure Helm in your environment, the process of creating and customizing Helm charts, best practices for package management in Kubernetes, troubleshooting techniques for common issues. Remember, these assignments aren't just academic exercises, they mirror real-world scenarios you'll encounter in production environments. Take your time to understand each step and experiment with different configurations. Let's tackle Assignment 1, which focuses on setting up your Helm environment. This is a crucial first step in your Helm journey. The assignment involves 3 key steps. First, installing Helm. You'll download and install the Helm binary from the official website. This process varies slightly by operating system, but the official documentation provides clear instructions for each platform. Second, verification. This step ensures your installation is working correctly. You'll learn to check Helm's version and verify its connection to your Kubernetes cluster. Third, initialization. Running Helm init sets up your local Helm environment. Though this command is primarily relevant for Helm 2, understanding its purpose helps you grasp Helm's architecture. What you'll learn from this assignment: how to properly set up a Helm development environment, understanding Helm's relationship with Kubernetes, basic troubleshooting of installation issues, how to verify your setup is working correctly. This knowledge is fundamental. A properly configured local environment may prevent numerous issues down the line. Take time to understand each step, as this foundation will support all your future work with Helm. Assignment 2 introduces you to creating your first Helm chart. This is where you'll start putting theory into practice. The assignment focuses on using the Helm create command to generate a new chart for a web application. This command creates a scaffold with all the necessary files and directories, following Helm's best practices. When you run Helm Create My Web App, Helm generates a complete chart structure with default configurations. This includes a properly formatted chart.yaml file, a templates directory with common Kubernetes resources, a values.yaml file with default configurations, helper templates and test files. What makes this assignment valuable? You'll understand the standard structure of a Helm chart. You'll see how different components relate to each other. You'll have a foundation for creating custom charts. You'll learn about Helm's built-in best practices. In production environments, you'll often start with Helm Create and then customize the generated files for your specific needs. Understanding this starting point is crucial for efficient chart development. Assignment 3 delves into the chart structure created by the Helm create command. This assignment helps you understand each component of a Helm chart in detail. Let's examine the directory structure. Chart.yaml, the metadata file for your chart. Charts / directory for chart dependencies. templates / contains all your Kubernetes resource. Templates _ helpers.tpl common template helpers. Notes.txt installation notes for chart users. Tests / chart test files. Understanding this structure is crucial because it follows Helm's established conventions. It makes your charts maintainable and shareable. It provides a framework for organizing complex applications. It includes testing capabilities out of the box. Many DevOps teams benefit from this standardized structure as it makes charts easier to review, maintain, and share across teams. Pay special attention to the templates directory, as this is where most of your customization will happen. Assignment 4 focuses on customizing the values.yaml file, which is crucial for making your chart configurable and reusable. In this assignment, you'll set the replica count for your application, configure the image repository and tag, define service settings, understand value overrides. The example shows basic configurations: replica count, 3, image, repository, engine, X, tag, latest, service, type, cluster IP. What you'll learn: how to structure your values file, best practices for configuration management, how to make your chart flexible and reusable, the relationship between values and templates. A well-designed values.yaml file is crucial for environment-specific configurations, easy updates and rollbacks, documentation of configuration options, maintaining consistency across deployments. Remember, while latest tag is used in the example, in production, you should always use specific version tags for predictability and security. Assignment 5 deals with modifying the deployment.yaml template, which defines how your application will run in Kubernetes. The template demonstrates several important concepts: dynamic naming using release.name, configuration injection from values.yaml, label management for service discovery, container specification, and port configuration. Key learning points include how to use Helm templating syntax, managing metadata and labels, configuring containers properly, understanding template functions. In production scenarios, you'll likely need to add resource limits and requests, health checks and probes, volume mounts, environment variables, security contexts. Getting the deployment template right is crucial because it directly affects application reliability, resource utilization, scalability, maintenance operations. Assignment 6 focuses on creating the service.yaml file, which defines how your application is exposed within the Kubernetes cluster. The service template includes dynamic service naming, selector configuration, port mappings, protocol specification. Key aspects to understand: how services enable discovery, port configuration best practices, label selector importance, service types, and their uses. In production environments, you might need to consider multiple port configurations, session affinity settings, external traffic policy, load balancer configurations, service annotations. Many teams struggle with service configuration, especially when dealing with microservice communication, external access requirements, load balancing needs, security considerations. This knowledge is essential for creating robust, production-ready applications in Kubernetes. The final assignment brings everything together, taking you through the process of packaging, installing, and verifying your Helm chart. Key steps include: 1. Packaging your chart with Helm package MyWebAppI. 2. Installing the package chart. 3. Verifying the deployment. 4. Accessing your application. This assignment teaches you how to create deployable chart packages, installation and upgrade procedures, deployment verification methods, troubleshooting techniques. Real-world applications: continuous deployment pipelines, version management, release strategies, monitoring, and verification. I've found these skills particularly valuable when managing multiple environments, implementing CI/CD pipelines, handling production deployments, training new team members. We've covered a lot of ground in this module on Kubernetes package management using Helm. Let's take a moment to summarize our journey and consider what comes next. Throughout this module, we've progressed from basic concepts to practical implementations. We started with a simple Hello World chart, learning the fundamental structure and components of Helm charts. We advanced to a more complex guestbook application, exploring multi-service deployments. We covered essential Helm commands for managing your deployments. Through hands-on assignments, you've learned how to create, customize, and deploy your own charts. The skills you've gained are directly applicable to real-world DevOps scenarios. Package management for microservices architectures. Configuration management across different environments. Standardized application deployment. Version control of infrastructure code. I encourage you to practice these concepts in your own environment. Try creating charts for applications you're familiar with. Experiment with different configuration options. Test deployment scenarios with various override values. Practice troubleshooting common issues. Do you have any questions about chart structure and best practices, template syntax and functions, values configuration and overrides, production deployment considerations, real-world implementation challenges? Remember, the best way to master Helm is through practice. Set up a test cluster, create your own charts, break things, and learn from the experience. The skills you're developing are increasingly valuable in the DevOps field. Feel free to post your questions in the discussion forum, where we can explore these topics further and learn from each other's experiences. Thank you for your participation, and I look forward to seeing your progress in implementing these concepts.